We have decided to combine physics and multivariable calculus to determine which coin will win the race. First, we had to calculate the mass by using the given density. For the first coin, Chaos, the density was 7 grams per centimeter cubed, the radius was 1 centimeter, and the thickness was 0.15 centimeters. We then plugged in the density for the integrand, used the radius and the thickness for the bounds, and solved the triple integral. The final answer was 3.2987 grams. Next, we needed to find the second moment of inertia. To do so, we had to do 3 triple integrals, one in the xy plane, one in the yz plane, and one in the xz plane. But we will just show you the xy plane for time's sake. The integral for the second moment of inertia is similar to the mass integral, except the integrand is the density multiplied by one of the variables, in this case z, and that variable is squared. The answer to the second moment of inertia in the xy plane was 0.02474. Once we had the second moment of inertia, we calculated the second moment of inertia for the remaining 2 planes.
Here is the second moment of inertia in the xz plane. Here is the second moment of inertia in the yz plane.
We add the moments of inertia in the 3 planes to find the polar moment of inertia, which is 1.674 grams squared centimeters. We will use this moment of inertia to calculate the final velocity. Here is a representation of the hill that the coins will be racing down. It is 1 meter high, 2 meters wide, giving the hypotenuse a length of root 5 meters. The first thing we had to do was find the final velocity. To do so, we decided to use the conservation of energy theorem. This theorem states that energy initial equals energy final. Since the coin is starting from rest, the energy initial equals the mass multiplied by the gravitational constant, which is then multiplied by the height. Since the mass is rotating on its way down, the energy final contains translational kinetic energy as well as rotational kinetic energy. The translational kinetic energy is 1/2 mv squared, and the rotational kinetic energy is 1/2 I omega squared. Here is Jonny using the conservation of energy theorem to solve for the final velocity. The answer we got for the final velocity was 3.606 meters per second. Before we could solve for time, we first had to determine what the coin's acceleration would be. To do this, we used the kinematic equation that states v final squared equals v naught squared plus 2a delta x. The answer we got for acceleration for Chaos was 2.908 meters per second squared. We finally have enough information to calculate the time it takes for Chaos to get to the bottom of the hill. To do this, we use the kinematics equation v equals v naught plus at. The time it took for Chaos to get to the bottom of the hill was 1.24 seconds. After repeating the process for the next 4 coins, we can see that Ashweezy was the winner by a small margin. He took a total time of 1.237 seconds to reach the bottom of the hill. Congratulations, Astroweezy. Since we now know which coin will win, we can place our bets accordingly and bring in the money.